In this section, we're going to talk about transformations of graphs. And our objectives are graph functions using vertical and horizontal shifts, stretching and shrinking, using reflections, and a combination of all these transformations. So the transformations that we're going to cover here are summarized in this table. So make sure we have it referenced here. So let's see. If we have a function and on the outside we add c to it, then that's going to shift the graph upward c units. If we have a c and we're subtracting it on the outside of the function, and you'll see right now what I mean, the function is going to go down c units. If we have a value of c, and the c is on the inside of the function and it's being subtracted, this is a horizontal shift to the right c unit. So this one is the opposite effect. So if you notice, we have a minus right here. And our intuition might say, oh, it's to the left, but no, it's to the right. The next one, if I have a plus c, then it's going to move to the left c units. Now for vertical stretches and shrinks. So if I have a value, a number on the outside of the function being multiplied, and if that number is bigger than 1, then that's going to be a vertical stretch. But if that number is between 0 and 1, a fraction, a decimal between 0 and 1, then the graph is going to shrink. The next one, if I have a value of c, a number, let's say, and it's on the inside of the function being multiplied, and if c is bigger than 1, then you're going to have a horizontal shrink. And again, it's like the opposite effect. A number bigger than 1, you might think, no, it's going to stretch it. It actually shrinks it. And if you have a value, a number that's between 0 and 1, a fraction or a decimal between 0 and 1, then that's actually going to stretch your graph, again, horizontally. The last type of transformation, if you have a negative and it's on the outside being multiplied, like a -1 on the outside being multiplied, that's going to be a reflection across the x-axis. And if you have a negative on the inside of the function being multiplied, that's going to be a reflection across the y-axis. So now let's practice these. It says, this is very important. The order of transformations may result in a different graph or equation. So always use order of operations. Excuse me. And you'll see right now the examples that we do. So example, write the equation of the graph. So you need to know that this is a parabola. So this kid is a parabola. So that means that I'm writing what I'm thinking I'm going to say. So the kid is a parabola. So that means that the parent also needs to be a parabola. And the most purest parent without any transformations is going to be x squared. And if I make a table for the parent, So x and y is equal to x squared. And I pick positive 2, so 2 squared is 4. If I pick a negative 2 squared is also 4. If I pick 0 squared is 0. And if I pick positive 1 squared is 1. But also negative 1 will give me 1. So I'm going to graph it. So here's 0, 0, 1, 1, negative 1, 1, excuse me, 2, 4, and negative 2, 4. So here's the parent. Here's the parent. And so here, hopefully we can see the following transformations. So it looks like, let me go here, just write it down. So for the transformations, it looks like we went 2 units to the right and then 3 units down to end up right here for the vertex. Same thing with this one right here. It looks like we went 2 units to the right and 3 units down to end up here. And the same thing with this one. It ends up right here. 2 units to the right. I think that's what I said. And 3 units down. So let me write that down. So it's going to be shifted to the right, 2, and shifted down 3. So this is how I create the children here. So I have f of x, and I always need to start off with the parent. So the parent is an x, and I have a squared. The squared is not a transformation. The squared is where the kid is coming from. So shifted to the right 3 units, shifted to the right 2 units, this part 1 right here, means that I need to put in the x inside a parentheses, not the squared, and to the right 2 means a minus 2. And then the next transformation, shifted down 3, means I'm going to put a minus 3, but on the outside. And I am saying that this is my answer. This is the equation for that graph. Now, I can check my work, so I'm going to. So there's x squared. And then the kid is parentheses x minus 2, parentheses squared, minus 3. And I am just going to confirm so I can zoom in here. I really don't have to. But I can confirm this is 2, negative 3, which is the same as this 2, negative 3. And then this point right here, how come it doesn't want to mark it, is 3, negative 2, which is this point right here, 3, negative 2. And on this side, I have 1, negative 2. Positive 1, negative 2. And so yes, my equation matches the graph for this kid. All right, next one. So this right here, we need to know, again, the kid. This is a kid. And I'm going to put him here. So the kid, it'd be nice for us to know, is a square root. So the parent also has to be a square root. Okay, so for the parent, if I'm going to make a table for it, we can only take the square root of positive numbers. So I'm going to have x, and I'm going to have y equal to square root of x. So the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So I'm going to go ahead and plot this parent here. So here's 0, 0, 1, 1, and 4, 2. And so here's the parent. And so what happened to this parent to produce this kid? So it looks like, let me come here. This point right here, we ended up going 1, 2, 3 spaces to the left to end up here. And let's see this one right here, 1, 2, 3 spaces. And this one right here, 1, 2, 3 spaces. So for all of these, the transformation is, let me write it down here. Shift to the left 3. So if I'm going to start writing the equation for this kid, again, I'm going to have, it could be f of x, it could be g, whatever equation variables you want. But you need to start off with the parent. So there's the parent. And if I'm going to shift left to the left 3, that means that inside the square root, I need to put a plus 3. This left 3 is plus 3. And the square root actually behaves like a parentheses. So these parentheses that I'm putting are really optional. And I leave it up to you to check the calculator that this in fact does work. All right, this next one. So now here we have a graph. We're going to call it the parent. And we want to sketch the graph of this kid. So this is the kid. This is the child or the kid. So we need to do the transformations in order, using order of operations. So I'm going to put order of operations. I should just put PEMDAS. Okay. So the first transformation is this x minus 1. So this x minus 1 is technically shift to the right 1. So I'm going to shift to the right 1. So every single point, I'm going to shift it to the right. And here's my kid. Actually, I should put them dotted. They're in utero yet. They're not born because we have another transformation to do. And then the minus 2 is going to be shift 2 down. So from here, I'm going to shift 2 units down. So each point right here, this one's going to go 2 units down. Then this one's going to go 2 units down. And so my answer here, there's my child. So let me highlight my answer. This is my answer. All right, next one. It says y is equal to negative f of x plus 1. Okay, so the transformations in PEMDAS order. Here we go. Transformations in PEMDAS order. So I don't have any parentheses. I don't have exponents. I do have a multiplication, the negative on the outside. So that one's first. So the negative on the outside is a reflection across the x-axis. Okay, so here we go. So I'm going to put this one in green. So reflection across the x-axis means that this point right here across the x-axis becomes this point. And this point, since it's on the x-axis, well, it'll stay there. And this one as well. So right now in utero, this is our kid. And then the last thing that we have, I'm going to put this plus 1. That plus 1 is going to shift up 1. So each point is going to be shifted up once, right here. Then this one's going to be shifted up once, right here. And this point is going to be shifted up once, right here. And so this right here is the graph of our child being born. Right there. That's our answer. Next one up. So now we have y is equal to f of 1/2 x. Okay. So here we only have one transformation. It's this one right here, this 1/2. So let me put here the transformation is the 1/2. It's on the inside being multiplied, and it's a number between 0 and 1. So if you go back to your table, when it's inside being multiplied, it's going to affect it horizontally. And when it's a number between 0 and 1, and it's being multiplied, it's going to be a stretch. And technically, it's going to be by a factor of 2. Now, I'm going to go back to the notes here, and I'm going to add something up here. So here on this one, when I have a vertical stretch, I'm going to add this right here. Multiply, or for shrinks anyway, so multiply the y's by whatever the value of c is. And for horizontal, technically what's happening algebraically with the y values, you're going to multiply my x's by the reciprocal. So that's the reason why on this problem right here, I'll put it here, a little note. The reciprocal of 1/2 is 2. And that's why it's a factor of 2. So let me highlight the 2 that I'm talking about. This 2 is that 2 right there. Okay. So let me continue here. Let me zoom in. Okay. So what does this mean? We're going to multiply the x's by 2. Therefore, oh, that's not what I wanted. So therefore, multiply the x's by 2. So this right here, -2 times a 2 is actually going to be -4. So this one's going to be -4, 0. And then this one is going to be 0 times a 2. Well, that's still 0. So that one's going to stay there. And then this 2, I'm going to multiply it by a 2. And that gives me 4. So this is going to be 4, 0. And so my kid is going to look like this. I definitely horizontally stretched them. And here in yellow is the answer for my kid. Last one of these. I have y is equal to 2 times -x. So on this one, again, taking this really slow. So I need to do the transformations in PEMDAS order. So I need to address the negative that's on the inside first. So a negative that's being it's an understood -1 that's being multiplied inside of a parentheses of the function. If you look back up at the table, it is a reflection across the y-axis. All right, so let's do that. So I'm going to do that in red. So this point right here, if I'm going to reflect it across the y-axis, becomes this point. And the original black point that was there becomes this point over here. And this black point right here, if I reflect it across the y-axis, well, it stays right there. So my first transformation is the exact original graph, but it's still in utero. And then the next transformation is going to be the multiplying by the 2. So looking up at the table again, if you see a value, a number on the outside being multiplied, and it's bigger than 1, then that's going to be a vertical stretch by a factor of 2. So what does that mean? This means that you're going to multiply your y values by 2. So therefore, multiply. So for vertical, it's the y's. For horizontal, it's the x's. But for vertical, it's going to be multiply the y's by 2. So this is going to be 0 times 2, which is still 0. So that is going to stay there. And this is going to be 2 times 2, which is 4. So this is going to be 0, 4. And this is going to be 0 times 2, which is 0, so it stays there. And so this is our kid. Let me highlight them. And there's our graph. Now, for here, we're going to actually start with a parabola. So here's our parabola. Y is equal to x squared. And we're going to do these transformations. So it says here, write a new function, f of x, that satisfies the following conditions. Do not simplify the formula. So I am going to split this in half. I'm going to get my Desmos here so that we can check our answers as we go. And here, if we were in a face-to-face class, we'd be guessing and checking and being first, second, and third place to see who would guess it. But here I'm just going to spoon feed. So here we go. All right, so shift it to the right 2 units and downwards 3 units. So again, the kid has to look like its parent. So I have to start off with an x and a squared. Again, it's not a transformation, it's coming from the parent. So shift it to the right 2 units. I'm going to use a different color code here. Shift it to the right 2 units means it has to be inside the parentheses. Again, the squared is not part of the parentheses. And I'm going to do a -2. And then I'm going to go down 3 units. That means that I have to put a -3 on the outside. So I wanted to show you here in steps, and I think I can pick. So let's see. I have parentheses x -2 parentheses squared, and I'm going to put it in green. So there's the kid in utero. I definitely moved the parent that was, I guess if I'm gonna do color coordinated here, I'm gonna put it black. So the black graph is the parent, and the kid in utero in green is definitely shifted 2 units to the right. And I can check with the vertex right there. It went from 0, 0 to 2, 0. And then the -3. So I'm going to have parentheses x -2 squared, and then -3. So before I put the -3, this blue graph, I want it to shift down 3 units for the kid to be born. And so it can match my color coding, should be red. So the one in black is the parent. This is the first transformation that we did, moving it 2 units to the right. And then the last transformation is going from the green graph, again still in utero, moving it 3 units down to have our kid. So we are confident that that one is correct. Okay, so the next one. So let's have another kid here. We're going to start off with the same parent. So it says shift it to the left 2 units. So again, always start off with the parent. An x and a squared. Shift it to the left 2 units. Okay, so then that means I need to put a parentheses. And to the left 2 units going to be plus 2. Okay, so let's check. Excuse me. Parentheses x plus 2 squared. Yep, it went 2 units to the left. Negative 2, 0. Good. And then the next transformation is that I'm going to reflect it about the x-axis. So if it's going to be the x-axis, that means, again, going back to your table on the previous page, I need a negative on the outside. So let's check it, because sometimes it's not going to work. So let's see. So negative parentheses x plus 2 squared. Oh. So the kid in green in utero, we want to reflect it across the x-axis. And yes, we definitely did. So this equation here is correct. Let's try the next kid. So part C says, reflect it about the x-axis first and then shift it to the left 2 units. Okay. So we start off with the parent first all the time. And then we're going to reflect it about the x-axis. So let's see, we're going to put a negative on the outside. Sorry, I should have put this here. Reflected about the x-axis. I'm going to go back, sorry. This is red. Okay. So let's see. Negative x squared. And I want it in green. That's not what I wanted to do. Stop. Yeah, it's definitely reflected about the x-axis. Now I'm going to shift it 2 units to the left. So if I'm going to shift it 2 units to the left, it's going to be inside of parentheses. And you might think it's like this, but again, if we were in class, we would be playing competitions, but it is what it is. And shift it to the left 2 units would be a plus 2. So let's check it. So you're like, okay, let's put a parentheses. Well, so parentheses negative x plus 2, and then I'm going to square it. So what I wanted is not what happened. I wanted this green graph to be shifted to the left 2 units. And it didn't quite work. It didn't quite work. And so here in essence what happens is that this one isn't it. I should mark it with a different marker. So I never erase. If I make a mistake, I just exit out because I still want to see it so that I don't do it again. Okay, so we had let's do the same color. So we had negative, and then we had an x, and then we had a squared. And here's technically what's happening. Let me tell you the problem. In order for, what can I say? In order for this negative, how can I highlight it? In order for this to, that's horrible, to be a reflection about the x-axis, it has to stay on the outside. So when we put the parentheses around it, all of a sudden that negative became on the inside. So it has to stay on the outside is technically the key. So here on this one, this is how we do it. And again, the x is being squared, but we also, the squared is from the parent. So really, to just show that the x is going to be shifted 2 units to the left, we put a +2. And so here we go. Let's try this one more time. See if it lets me put the negative parentheses there. And take that one off. And there it is. Here was our kid in utero in green, and we wanted it shifted 2 units to the left. Now, take a notice. These two, let me highlight somehow here. Shifted to the left 2 units, and then this one is shifted to the left 2 units. And then this one is also reflected about the x-axis, and this is reflected about the x-axis. So in this particular case, and it's not always the case, but I'm going to put it right here. This gave us a scenario where we had the same kid regardless of the order. So some of you are saying, Murga, you just told me that do it in PEMDAS order and we're getting the same kid. Well, wait for the next 2 examples. So here we go. So let's get rid of these. Now the next one. Shift it to the right 3 units. So again, the process. We start off with the parent. Shift it to the right 3 units means that we want a set of parentheses. And to the right is going to be a -3. And so here we go. Parentheses x -3, parentheses square. What happened? 3. And then squared. Yep, we shifted it to the right 3 units. That's this one right here. And I forgot the other red one, shifted to the left. Okay, so now reflect it about the y-axis. So if I'm going to reflect about the y-axis, I need to have a negative. And it needs to be on the inside. So let's try it right here. And let's see if it produces the kid. So this blue graph that we have here, if we're going to reflect it about the y-axis, we want it to end up on the left side of the parent, somewhere over here in quadrant 2, if we're going to reflect it across the y-axis. So let's see. So I have parentheses negative x minus 3, close it, squared. So here's the blue kid in utero. And if I reflect it across the y-axis, this is where it's supposed to end up. Again, because I'm reflecting it across the y-axis. So yes, it definitely works. So there it is. Now let's have this last one here. It says reflected, so the same parent. So we start off with a parent. Again, the squared is not a transformation. Reflected about the y-axis. So if I'm going to reflect it about the y-axis, the negative needs to be on the inside. So how am I going to show negative is going to be on the inside? I do this right here. So let's see. So parentheses negative x, close it, and then I'm going to square it. And so here's the kid there's the parent, excuse me. And if I reflect it across the y-axis, there's my kid in, hang tight. I want it in green. What? Listen to me, finger. Hold on. In green. Okay. So there's the parent, and I reflect it across the y-axis. Yep. I end up with the same parent because the origin is at, the vertex, excuse me, is at 0, 0. So yeah, it's the same parent that I reflect, and I get the same kid in utero. Okay, now I want this kid in utero in green to shift 3 units to the right. So you might, okay, so 3 units to the right, you're like, Murga, I have to move this parentheses here because 3 units to the right has to be on the inside according to your table. And to the right 3 units is going to be -3. So this one was reflected about the y-axis. And then to the right is going to be -3. Let's see if that's the case. So here I go. It's going to be parentheses -x -3, close it and square it. Well, there's my kid in utero. And there's my kid that's supposed to be born, shifted 3 units to the right. And it's not, it's 3 units to the left. So it's not right. So this is technically what's going on again. Let me write the parent again here. So here we had a negative. Oh, and let me get my color coded here. We had a negative on the inside, like this. But here's the clincher. The thing that's being shifted to the right is the x. So to make sure that it's only the x and not that negative in front of it, what we need to do is put some parentheses right here. And if I shifted 3 units to the right and I put a -3, it's going to work. So let's see. I want to put a set of parentheses here and another set of parentheses there. And so there's my kid in utero in green. And this one right here is, I want it in red. Hang tight. So there's the parent. The reflected about the y-axis. There's the reflection across the y-axis. And then the kid in utero in green shifted to the right 3 units. There it is. Now, if you want to clean it up, just for algebraic purposes, technically we could distribute this negative. And we would be left with parentheses -x +3 quantity squared. So let me clean that up here. Let's see, -x, and then change this to a plus. And again, there's a kid in utero. And then there's the kid born 3 units to the right. So kind of tricky. So here on this one, different kid. So I'm just going to put here, not the same kid. Even though we have the same transformations here. So let me highlight them. So we had, I'm having too much fun with my highlights. Shifted to the right, shifted to the right. And then here we have reflected about the y, reflected about the y. So sometimes you have the same kid, sometimes you don't. So in this one, y is equal to the absolute value of x. So the absolute value of x, hopefully we know now, is a v. There it is. And I'm going to put it black. So here it says you're going to shift it down 3 units. So we always start. So we always start with the parent. So this is the parent. So I'm going to leave some spaces here. That's the parent. And we're going to shift it down 3 units. Okay. So down 3 units. So here it is. Absolute value of x minus 3. And we want it in, I'm going to run out of color here, in green. Yep, I shifted it down 3. And then I'm going to shift it to the right 4 units. So we said here to the right 4 units is going to be a minus 4. Let's check it. So the green kid in utero should shift 4 units to the right. So let's see. So there's the kid in utero. And then now shift it to the right 3 units. To the right, 4 units. So looking so far so good. Reflected with respect to the x-axis. So now with our kid in, so that we're not getting too confused, I'm going to not graph the, I guess, first trimester. So here on this one, we have shifted down 3 units and shifted to the right 4 units. Now this kid in utero in red, we want to reflect it across the x-axis. So we want to flip it across the x-axis. And so if we're going to flip across the x-axis, we need a negative on the outside. So this is our kid in utero. So all of it needs to be flipped. So let's see. So here's our kid in the first trimester, and then we're going to reflect it across the x-axis. Yep, it is definitely being flipped. Okay, so now I'm not going to graph this one anymore. So here's our parent. And now we have our kid in the second trimester. They've been shifted to the right, down 3, and reflected across the x-axis. And the last one is that we're going to vertically compress it or shrink. This is another name for shrink. I'm going to pick another color here. Compressed is another name for shrink by a factor of 2/3. So if you look at your table, that tells you to just multiply it by 2/3 here. So let me see. So this is going to be negative 2 divided by 3. And then parentheses, absolute value of x minus 4. Minus 3. And then close the parentheses. So let's see. Here's our kid, second trimester. And we're going to vertically compress it. So this point right here went down to this point right here. So my y value was before, it was a 3. Now my y value, because it was vertically compressed, is a 2. These obviously stayed the same because the y values were 0 and you can't compress nothing when it stays nothing. So it's definitely a compression. And there's the kid. So let me put the kid in a different color here. I guess blue for the last transformation. And so we're not going to graph this one anymore. So here's the parent. Oops. There's the parent. And then this is the kid with all the transformations done.